Hi, my name is Luke Brooks, and today I'm going to be doing problem 3 on project 1. Let me set this up. Whoa. Perfect. Alright, so problem 3. For part A, we have if big F of x equals the integral from a to x, 15t to the 2 pi d of t, we have to calculate f prime of x, and then use that calculation to evaluate f prime of 3. So right there, we're going to use fundamental theorem of calculus part 1. So for f prime of x, we are just going to plug in x where there's another variable. So the other variable is t. So f prime of x is going to equal 15x to the 2 pi. And then for f prime of 3, we're just going to plug in 3 where x is. So that's going f prime of 3 is going to equal 15 times 3 to the 2 pi, which is going to give us 14,925.62. And I'm just rounding to 2 decimal places throughout all these parts. So right here is our answer to part A. So for part B, we have if big F of x is an antiderivative of little f of x, which is 3e to the 0.2x plus 1, we are given f of 6, which is 39.86. So they're asking what is big F of 2. So right now, if big F of x is an antiderivative of little f of x, we know that that is going to equal the integral of little f of x d of x, which is going to equal big F of x plus c. And therefore, big F prime of x is going to equal f of x. Okay, so we know we have our original equation, and personally, I like to break them up when I'm finding derivatives. So we have the integral from 3e to the 0.2x plus the integral of 1. So here we are going to divide, we're going to do 3 divided by 0.2. So 3 divided by 0.2 is going to give us 15. And then whenever we have an e to an exponent, it's going to stay the same. So e to the 0.2x stays the same. And then your 1 is just going to be x. And then we have our plus constant, which is c. So f of 6, which is what we're going to find, we are going to take, since f of 6 equals 39.86, we're going to do 39.86 is going to be equal to that same equation we just found, but plug in 6 for x. So here we have 39.86 equals 15e to the 0.2 times 6 plus c. So we get all that math out, and over here on the right side, we're going to do 55.80 plus c. And then we're going to get c by itself, so we're going to subtract 55.8 from 39.86. That's going to give us negative 15.94, which is equals c. And you have to plug that back into this equation. So that's going to be big F of x is going to equal 15e to the 0.2x plus x minus 15.94. But we're not done yet because we have to find f of 2. But that's easy because all we have to do is f of 2 is going to equal that equation that I just said, and then we're going to plug in 2 where x is. And that is going to equal 8.44. So 8.44 is our f of 2. And then our f of 6 equation is this. For part C, we have if f of x is the rate of change of the size of a forest fire, measured in acres per minute, x minutes after midnight, write a sentence interpreting the statement, the integral from 2 to 30, f of x d of x equals 59. So we know right away that from 2 to 30, this is going to be our time. And then it's x minutes after midnight. So 2 is going to be 12:02 a.m. and 30 is going to be 12:30 a.m. There we go. And then we have our units as well. Actually, we'll put this from 12:02 a.m. to 12:30 a.m. is our first part. And then we know we're talking about the forest fire, and that it is increasing, or in their words, spreading because it's positive, by what? So as our integral, we know that this is our ending point. It is either increasing or decreasing by 59. So we know that the size of the forest fire is going to increase because if a forest fire can't really be negative. If it's at 0, it's non-existent. So we know that that is going to be positive. So that's our final. And then we have our units. So we plug the 59 in. So from 12:02 a.m. to 12:30 a.m., the forest fire spreads by 59. But 59 what? So our units are acres per minute and minute. So our minutes are going to cancel out and we're left with acres. So there's our final. So the final answer for C is from 12:02 a.m. to 12:30 a.m., the forest fire spreads by 59 acres. And that is all for problem 3 of project 1.